Hello everyone and welcome to PC Retro Tech. In this week's video I'm going to be revisiting the topic of 486 socket 3 motherboards. And you remember there was a series on the channel about this previously where I even overclocked a AMD 5x86 133 all the way to 160 megahertz, and we got an amazing Quake score of 16 frames per second. So let me just go through quickly the motherboards that I had previously. I've actually purchased some new ones for a new series of videos. The first one we tried though was the Opti 82C895 chipset. It was this motherboard here. It seems to be a relatively early board. The chipset is fine, but this board looks a bit ancient. You can see it has 30 pin RAM slots on it still. There are 72 pin ones here as well. Of course, all the boards that we looked at previously were Visa Local Bus, except I think one, which had some PCI slots. So this particular board had a little bit of a problem. We weren't able to get the AMD working at even 120 megahertz, so we had to content ourselves with overclocking the DX4100. We did get a nice 13 frames per second out of this in the end. So this board is probably just a little bit too early, and I've actually managed to purchase a newer Opti 82C895 Visa Local Bus board. It just has all 72 pin RAM slots, and we'll try that this week and see whether we can get further with that board than we could with this earlier one. The next board that we tried was this VIA one with an 82C505 chipset. And unfortunately this board had a few problems. So first of all, one of the Visa Local Bus slots was faulty. That's not a major problem, but we also had the issue that whenever I overclocked anything on this board, the cache and memory timings would get much worse just automatically. And so we ended up, even at 160 megahertz with the AMD chip, with a dismal score of 11.1 frames per second on this board. Eventually some viewers suggested that it had better luck with the SIS chipset, and so I got this board based on the 85C471. Unfortunately I had a little bit of a problem with this board. I did get a higher score out of it, but I couldn't get the AMD 5x86 working correctly. So normally you want a multiplier of 4, and many earlier boards don't support that. So they were designed so that if you set them up as a DX2, they would run with that multiplier. But unfortunately, I could only get a multiplier of 3 on this board for reasons unknown. So I had to jack up the front side bus speed instead, which I managed to get to 50 megahertz. And so that gave us 150 megahertz overall and a score of 13.8, which was certainly very good, but it was a little bit disappointing that we weren't able to get it all the way to the maximum of 160. Eventually I read online that the UMC chipset boards perform particularly well, and so I actually decided to get hold of this Octec board here, presumably based on the UMC 8498F chipset. This board indeed performed fantastically well. It seems to be an extremely flexible board. Unfortunately this particular one had a faulty Visa Local Bus slot, but that wasn't a major issue. But I did manage to get all the way up to 160 megahertz with this, and we got a score of 15.9 frames per second in the Quake benchmark. And finally there was this board here, another UMC 8498F chipset board, and this one performed just as well as the other one, in fact just slightly better. We actually got a 15.9 frames per second at one point out of it. Moreover, I made a few changes to the video card, just changed some jumpers, and actually managed to get 16 frames per second. So this board currently holds the record for the channel, but I wondered after making that video, you know, these UMC chipset boards seem very flexible and very good, but maybe I was a little unfair to some of the other chipset brands. So in particular I want to try an Opti board this week that's a little bit more recent and see whether that actually performs better than I thought. And I found another socket 3 motherboard lying around, which I don't know how I missed it the first time around when I made a video, but it was just lying on my shelf. So we're going to try that one out. So let me show you those two boards. This is the second Opti 82C895 board. You can see that it's only 72 pin RAM this time, and so I have hopes that this is a more recent board and will actually perform better. So let's see if we can push this one a little bit harder than we managed to push the other Opti board that I tried. And then there's this board. This seems to have an EFA chipset, EC802G. I don't know very much about this board at all. I just found it on my shelf sitting there unused. It is VESA local bus, it is socket 3, it has 72 pin RAM and cache, so it should have qualified for our video, but it may just not be very flexible. So we're going to try this out in this video and see what it can and can't do. And then in a later set of videos, I'm going to start looking at PCI boards. Let me explain why that is. I found this article online by Jan Steunebrink on the AMD 5x86. It's a really great article, by the way. If you want to check it out, there's a link in the description. And he goes into a whole load of detail about how to get that chip working on various 486 boards. And in this portion of the article, he gives a list of chipsets that support the write-back mode for the L1 cache, which we know that the AMD 5x86 has. So I started looking for boards online that had the later ALI, Opti, SIS or UMC chipsets, and I didn't really find any cheap VESA local bus ones that had those, if any. I did find some very, very expensive VESA local bus boards. It seems that some people want 250, 300, even 400 euros for a VESA local bus board these days. The cynical part of me just says that they're scalping and there's nothing special about the boards at all. But I did find some reasonably priced PCI boards. And the reason that I mention that here is because I found a post online saying that all of the records for the socket 3 boards are set using PCI. And this makes a little bit more sense because it was the latest standard, and of course by the time boards came out with these chips, these later chipsets on them, they were well into the Pentium era, so technology had improved quite a lot. So I did manage to obtain some boards with these later chipsets, all PCI, and you'll see those in a later video. For now though, I'm going to stick just with the VESA local bus and see if we can push anything else out of that before I move on to the PCI stuff. The EFA board has this marking on it, IH4077D. That turns out to be the model of the board. That's actually written on this sticker on the side of the PCI slot here, and it's probably a little bit hard to see that far away, but there's also a sticker on the BIOS chip there, which says essentially the same thing. And lo and behold, the settings for this are actually available online. That makes this a MyTAC board. And in fact it actually supports the DX2 and DX4. So we should be able to set this up, I think, to run both the Intel chip and the AMD one. I'm going to try the Intel one first just to make sure the board is working, and then we'll switch over to the AMD. I just have the board sitting on the edge of my bench at the moment, and one of the things that gives me hope about this board is that it has onboard IDE and floppy controller. So this probably means that it's a fairly late board, and with any luck it'll work with the AMD chip. Now I just have a DX266 in it at the moment. That was just whatever was in it when it was sitting on my shelf. And it seems to be configured for that. So let's give that a whirl and just make sure that it works with that chip. Well, there's no fan, but I can hear the power supply, and yeah, it seems to be working. So I've just put 32 megabytes of fast page memory in it. Pretty sure this board doesn't support Edo. So I'm now going to set it up with a hard drive, and I'll put the DX4100 in. Well, that escalated quickly. I think there are some major problems with this board. When I try to put in a CPU with write-back cache, even though the BIOS has options for write through and write back, it won't even post, just a black screen. It works with ones with write through cache, but when I put in an Intel DX4100, it boots up as a 75 MHz CPU, and I've checked that the settings are correct on the jumpers, both according to the manual and according to the motherboard. Moreover, many of the jumpers are actually just hardwired. I mean, this is not a problem because those settings are the same for both DX2 and DX4, so that won't affect us. But yeah, it's just really strange that the manual mentions all of these and they actually can't be set. Then there's a problem with the cache itself. So if I try to boot into anything, even DOS, it'll tell me command com is missing, or it'll just hang, and so on if I have the external cache enabled. Now I have checked that the settings on the board are correct for the cache. So at this point I'm beginning to suspect that the actual cache chips are faulty. So I'm going to pop those out and try and replace those and see if I can get a little bit further. But if it won't work with any write-back CPUs whatsoever, then there's no hope of it working with the AMD 5x86. I'm just going to pull one cache chip from the old Opti board using this professional chip puller, and we'll stick that into each of the slots in turn on the other board to try and find if there's a single cache chip faulty on the other board. Of course, if there's more than one, I'm going to have a lot of work ahead of me here, but this is probably the easiest way to narrow down if we have a single failure. Well, I found the culprit. It's this cache chip here. Of course, it was the 9th one that I tried. But yeah, I took this in and out multiple times just to make absolutely certain that it's dead. And this is a dead part. So obviously we need to send that to a good home. And now I want to check whether or not the board works with the write-back CPUs now that we've fixed the cache. I don't expect that it will, but you never know until you try. And the answer is no. So all of the chips on the right are write-back cache, and all of the ones on the left are write-through. And these all work, these all don't. Moreover, the Intel DX4s, there's actually 2 of them here, both boot up as 75 megahertz, whereas the AMD one boots up as 100. So that problem hasn't gone away either. Since there's just no settings on the board or in the manual for changing between write-back and write-through cache, I just have to conclude that this board does not support these CPUs, regardless of what the BIOS says. And in fact, if I set the cache to write-back, these work just fine. So I don't think there is a way of setting it on this board. So that's a little bit of a shame. That means this board is out of the running. It's not going to help us at all with our benchmarking, but at least I have the board working now and can use it for some other purpose. Alright, so let's move on to our second Opti board and see whether we get more out of that. Well, this is the Opti board, and there are no markings on it to tell me what brand or model number this is. There are quite a lot of jumpers as well, so it's going to be difficult to set up without a manual. And there are some that are marked, for example SXDX, this is marked AMD, Intel or Cyrix, and there are some markings here for jumpers for the front side bus and for the cache. So it's not a total lost cause, but it'd be nice to have a manual for this. Something curious is that there appears to be a voltage regulator missing here, and the voltage regulators are actually labelled here, so you can look them up. So this one is for a 3.3 volt voltage regulator. That got me a little bit worried, but apparently this one is a variable one. So what I'm going to do is have a quick look online and see if I can identify this board, and maybe we can find a manual for it. Well, that didn't take nearly as much effort as I thought. I had a look online and found a number of boards which are identical to this one, even down to the chip. The only difference was that they had a red PCB instead of a green one. Anyway, those boards are Shuttle HOT-419 boards, and I found the manual here. You can see that it just has the one voltage regulator installed instead of the 2, but I was able to find boards with both of them installed. At any rate, we have all of the jumper settings now, and I can go ahead and set it up. First, I think for a DX4100, just to make sure it works, and then we'll try to set it up for the AMD chip. Well, it does seem to boot up with the DX4100 in there, and if I go into the BIOS here, you can see that it's just the very primitive AMI BIOS, as is common with these boards. But I'll get to setting this up, and we'll see if we can get some timings out of it. Well, I didn't have any problems setting it up, and I've already got a Quake score here for the Intel DX4100 that just has write-through cache, as you would have seen earlier. And we got a score of 9.9 frames per second in Quake here. So what I'm going to do now is put the AMD 5x86 in, just at 133 megahertz initially, and we'll see what score we get. In order to get the AMD 5x86 chip working, the manual really only mentions one jumper, and that's this one here for the CPU multiplier. It's currently set at 3, and if I stick it on the other end it'll be set at 2, which is what you want for this chip. Apparently internally it recognizes that as 4, and so for example 4 times 33 megahertz would be 133, which is what it's rated to run at. The only thing is, there are other jumpers here that seem relevant. This here is perhaps a resistor pack, this long thin thing, and it's currently set in the Intel position, and one presumes that it should be at the other end, which is the AMD position, although the manual doesn't seem to be very clear about that. So I'm going to have a bit of a fiddle and see if I can get this chip to start up, and then we'll get some timings. Well, I'm hearing all the right sounds, and indeed it looks like it's actually posting. Let's just have a look and see what it detects this as. And it says AM486DX Plus, which, well, let's hope that's right. So I'm going to try and do a benchmark now and see what we get. Well, it is running, and relatively smoothly at that. Nothing to write home about at this point. But let's take a look and see what benchmark score it gives us. And oh, 9.9, that's exactly the same as with the Intel chip. So something's definitely gone wrong there. So let's have a bit more of a fiddle around with this and see whether we can figure out what it needs in terms of settings. Well, that is interesting. So I set it to Intel instead of AMD, and now I get 11.5 frames per second. Which I really wasn't expecting. I also tried a multiplier of 3 instead of 2, but naturally that made no difference at all. So it seems to be ignoring the multiplier, which is not really what I would expect. I'm going to try a few other settings, and then I'll fiddle around with the BIOS and see if we can get some better memory and cache timings. Well, what I decided to do was just to switch to 40 megahertz frontside bus and the multiplier of 2, which should internally be 4. And that actually seems to work. I get 13.9 frames per second, and I haven't done any fiddling with the BIOS yet. So I'm pretty sure that this is actually running at 160 megahertz at the moment. So now it's just a matter of fiddling around until I get good memory and cache timings, and I may have to, of course, try lots of different sticks of RAM. This particular board doesn't support Edo, so we're out of luck there. But I think we can probably get this score a little higher, and this is definitely already way better than we got with the original Opti board. Oh boy, we actually broke the record for the channel. So the previous record was 16 frames a second with a UMC board. This is an Opti board, and I'm getting 16.2. I have all of the BIOS settings just completely maxed out here, and it is totally stable. I am really impressed. I don't think there's anything more that I can get out of this. I think 16.2 is the limit. But let me show you what I changed in the BIOS. The first thing that I changed is the memory write weight state from 1 down to 0, and that already brought it up to 14.3 frames per second. So then I moved on to the DRAM burst cycle here, and that was at 5444. And so I've changed that to 3222, and that brought it up to 15.7 already. And then I went down to the cache read cycle here, which is at 3222, and I put that down to 2111, and that gave us 16.2 frames a second. So you tell me if there's anything else that I've missed here that would make a difference to the performance. I don't think there would be anything. I think we have everything pretty much maxed out here. I'll try fiddling around with things like the AT cycle, which at the moment is on 3. I'll set that on 0. I don't think we can do better. Well, actually it turns out we can do better. I'll set that to 3. And that's about all I can really see that I can change here. So I don't think we're going to get any more out of it, but that is really remarkable. So this proves my contention, and the reason that I bought this board is that it's actually not just the chipset that's the problem with a lot of these motherboards. It's actually the motherboard itself, and we saw that with the old Opti board. It just really didn't support this CPU, but if you get one that does, and it does look like you have to more or less luck into one that does, then you can get some really stunning timings out of this. Well, before we move on, guys, take a look at this. 16.6 frames per second. And just to put that into context, the highest score that I've ever seen anywhere for a socket 3 board was 17 frames per second, and I'm pretty sure that was set with one of these really fancy and extremely rare AMD chips that goes up to like 180 or 200 megahertz, which this one certainly does not. So the thing that made all the difference is I took another look at the motherboard manual, and whereas all the other settings were listed in tables, there's another portion there for the AMD 5x86 P75 chip, which is what this is, and it actually just shows all the settings in a diagram, which I'd completely overlooked for that reason. So it turns out that you are supposed to set it to the Intel setting, not the AMD, which we'd already worked out. But then P24D, which is normally DX2, then you have to set another jumper 59, which is associated with that, which sets between write back cache and write through cache for the P24D. And when you set that to write back, this is the result, 16.6 frames per second. I can scarcely believe that this is an Opti board doing this. So once again, we have smashed the record for the channel, and 16.6 is the new record on PC Retro Tech. So now I want to move on, as I said, to the VIA board. I'm pretty sure I'm not getting any more out of this one. The VIA board is PCI, as I said, and it was very, very slow when we tried it before, but now that we know so much more about how to set this chip up, maybe we can squeeze a little bit more out of it than we did previously. This is the VIA board that I'm talking about. It's based on the VT82C505 chipset, and as you can see, it's got a PCI implementation, albeit a very early one. It's an FIC board, and the model number is 486VIP-IO between the two PCI slots here. And you might remember that I said there are a few problems with this board. For example, the Visa local bus slot down the bottom here doesn't work, and if I recall correctly, that's due to a missing trace. That's not going to be a major issue for us because we have a floppy controller and a hard drive controller on board. But the other issue with this board is that we were unable to get the 5x86 working properly on it, and the cache and memory timings seem to slow down whenever we try to overclock the board. So what I'm going to try and do today is get the 5x86 working on this, perhaps by setting it up as a P24D and try to find a jumper for setting the write back cache to on, and maybe we can get a little bit more out of this. So previously the highest score that I got out of this board was just 13 frames per second, and I couldn't help the feeling that I just hadn't tried hard enough to get things going. So let's give that a go, and then if we can get that going, we can plug in some PCI cards and get some timings with that instead of the Visa local bus. Well, I've been at it for about an hour now, guys, and I don't seem to be having a lot of luck, although I have managed to get the 5x86 chip to power up. I've set the front side bus to 40 MHz, which is these jumpers here at the back, which is easy to do. But I have no idea what CPU it's set up as at the moment. I tried DX4100, P24D, P24C, anything that's not 5 volts basically, but it seems to be running really, really slowly. So the first problem is that if I set the multiplier to 3, you'd expect 120 megahertz, but I only seem to be getting 100, and I'll get a frame rate of like 9.9, which is what you'd expect from a stock DX4100. But if I set the multiplier as 2, which should give me internally 4 times, and so 160 megahertz, I get a frame rate of 8.8, which is even slower again. So it's really clear that the 2 times multiplier just isn't working here. So what I'm going to do is get out the multimeter and try and trace the pin that controls the 2 times multiplier to the board and see which jumper is supposed to set that. The way to do this is to set your multimeter to continuity mode so that it beeps when there's a short, and then you have to put a probe into R17. So ignore the outer layer of pins here because they're not used by the 5x86. And so the numbering starts from A here and proceeds down. It skips I and it skips O, and so you end up with RS. So in other words, R will be the 3rd row up. and the numbering is 1 through 17, and so 17 will be the second row in. And now you should be able to check easily. There'll be a beep whenever there's a short, and just look around for which pin here is connected to this. And it should be one of these three here, because this is where the multiplier jumper goes, and indeed the middle pin here is actually connected to R17. So now what I want is for one of these two to be connected to ground. If that's the case, then it will be shorting this R17 to ground when there's a jumper on it. So I'll just stick the other multimeter probe into ground, which is any of the middle pins in the power connector, and you can see that I don't get any short on either side here. So I was wondering for quite a while whether this is the reason why I wasn't getting 2 times, but I've since discovered that if I stick the multimeter on ohm mode and put the connector on ground again and try it this way, I get a reading of around about 1 kiloohm. Now that's actually okay, because the resistor that's being used to pull it down to ground, it doesn't have to be 0 ohms. It can be a low value like 1K, and so it is actually pulling it down to ground if there is a jumper across these 2 pins, which is exactly what the manual says. So as far as I can tell, this board is set up correctly to do a 2 times multiplier, but I still haven't been able to get this AMD chip to work. So I'm going to go back at it and try fiddling more with the jumpers. I must be missing something somewhere. Well, it's the next day now, and I've been at this board for literally 8 hours, I think, and I finally made some progress. In the manual for the board, which I downloaded from the Vogons forum, there's a mention of this 3.3 volt regulator and a 3.3 volt daughter board. And also JC10 mentions this regulator again, but I wasn't able to find JC10 on this board, or indeed 9, and I assumed that they weren't present on this particular revision, or maybe they were on the daughter board itself, which I don't have, of course. But after quite a lot of other fiddling with jumpers, going through every possible setting of CPU, I finally realized that maybe these jumpers are there somewhere, and went hunting for them and eventually found JC9. And that gave me the idea that maybe JC10 is there somewhere as well. It's really, really badly labeled, which is why I'd overlooked it, but I eventually found it after really quite a lot of searching. And when I set this correctly, it wasn't set correctly, of course, for the Intel DX4, then things started to work. So I don't have it set up as a P24D, that doesn't seem to work, but when I set it up as an Intel DX4, it actually seems to give reasonable performance. So let me show you what we have now. Now strangely, it recognizes a 132 megahertz CPU, which is weird because I have it set as a frontside bus of 40 and a multiplier of 2, so you'd think if anything it would say 80. But at least we're getting a reasonable frame rate now of 12.8, which is certainly a lot better than the 9.9 I was getting. So what I'm going to do now is go into the BIOS and set the memory options and cache options for optimal, and see if I can get an even better score. The settings that worked for me were to enable decoupled refresh. This made quite a big difference, about 0.4 frames per second. I had to leave this as right through. I'm not exactly sure why, but this is the external cache anyway. You can enable the alter and tag bits combining. Didn't make any difference for me, but the cache timing control did make a difference. So let's set that on the fastest option, which I presume is turbo, and we can also set fast DRAM. Now this didn't make any difference to me, so we'll enable both of those. Burst write has to be off, otherwise the machine doesn't even boot, and I just enabled both of these even though I didn't actually notice any difference. So let's see how this looks with all of that turned on. It's really a lot smoother, and I'm sure that the frame rate here is going to be quite a bit higher. and indeed it gives us a score of 13.7, which isn't too bad. Now, I don't know whether this is the most that I can get out of this board. I'm going to have a little bit more of a fiddle and see if there's some more, because remember we got 16.6 with the Opti board and 16 with the UMC board, so we're still a long way short of that, and we would expect to get a better score. Well, I did actually get another 0.1 frames a second out of it, so we're now at 13.8, and it's a really weird way that I managed this. I actually put in some 60 nanosecond RAM, some of which is explicitly labeled as Edo, so I know this is really Edo RAM. Now, the manual doesn't say anything at all about supporting Edo RAM, but it seems to accept a small number of the Edo chips that I have, only about 5 of them in total. So I've got 16 megabytes of Edo RAM in there, and this seems to be working. I have no idea why, but it gives just a little bit faster performance. Well, now I'm making some progress, 14.5 frames per second. And remember that in the first series on socket 3 on the channel, the fastest I got from this board was 13 frames a second. So we really have made significant progress here. And the way I've done this is to run the front side bus at 50 and the multiplier at 3, so that would give me 150 megahertz instead of the 160 that I was at before. But running the front side bus at a faster speed is actually, in this case, better than running the processor at the faster speed, which really surprises me because that wasn't the experience we had on the channel previously. Now, I did have to slow down the Visa local bus just slightly with some jumpers on the main board, otherwise it would crash about 2/3 of the way through the benchmark. But this seems to be quite reliable. So I think this now is as far as we can take this chip with a Visa local bus. So what I'm going to do now is try out the PCI implementation and see whether I can get a video card to work at this speed with a PCI card. Well, many of my cards won't even let the machine boot when I put them in, and that includes an Sanglabs ET6000, which is really pretty surprising. But a lot of the other cards do this, which is pretty awful to look at. So obviously many of these don't like the 50 megahertz front side bus. Occasionally it comes good, as you can see, but yeah, then it goes right back to being very bad. So I'm going to go through all of my PCI cards. I really have a lot of them, and see if I can find some that actually work. Well, I've been through all of my PCI video cards, all 34 of them in total, and I've divided them into 3 piles. So the pile on the right, the big pile with 26 cards, is all the ones that either the machine didn't boot at all, or there was just massive corruption when I ran the benchmark. Now, in the middle here is just one card. It's a Cirrus Logic card, which actually did work, but it gave a slower performance than the Visa local bus. So this gave 14.2 frames per second. And on the left here, I've got 7 cards which did work. Now, I accepted those if they had a very small occasional glitch which you really wouldn't notice, or if they were perfect, and many of them were. And that actually includes an ET6000, incidentally. It seems to be completely random which of these cards works well and which of them don't. So one ET6000 works, another doesn't. One Matrix card works, another doesn't. One S3 card works, another doesn't, and so on. So it's just completely random. I think it probably depends more on the week that the memory chips were made, to be honest. But anyway, these 7 worked perfectly, and I guess you're wondering what score they got. And it's 14.5, exactly the same as the fastest Visa local bus card that we have, the ET4000. So this is perhaps a little bit of a surprise, but I think the PCI implementation is not all that great on this particular motherboard. So I've actually purchased 3 additional motherboards with much better chipsets. There's an SIS, a UMC, and an ALI board. And we're going to see those in later videos, and I'm going to go through these PCI cards again on those boards and see if we can push the score even higher. So our record is 16.6 so far. So if you'd like to see us try and beat that in a later video, don't forget to like and subscribe. And don't forget to put the bell icon on so you get notified when a video gets uploaded. Anyway, that's all I have time for this week. Thanks very much for watching, and we'll see you in a later video. Bye.